Okay, today we are going to start with maths chapter applications of trigonometry, or you can also call it heights and distances. Okay, so this is one common chapter, one more common chapter of CBSE and ICSE boards. So they will have the same video for this chapter. Okay, so don't think that okay, this is not in my syllabus. This is absolutely same chapter in both the education boards. Okay, so don't worry about it. Let's start with the chapter. It's a very interesting chapter, very easy chapter actually. If you know a little bit of trigonometry, the basics of trigonometry, then you can easily do this chapter. So it is the applications of trigonometry. Okay, let's see how to do it. So very important part in this chapter is after reading the word problem, there will be all word problems. Okay, uh, no direct expression, or you can say numericals involving only numbers. There will be word problem. You have to read the word problem, understand it, and then make a diagram based on it, and then solve it further. Acha, one more thing you will need for solving these kind of questions, that is based on applications of trigonometry, heights and distances, is SOHCAHTOA. I'm sure you know, all know what is SOHCAHTOA. SOHCAHTOA. So S means sine, OH. O means opposite, H means hypotenuse. So sine, the ratio of sine is opposite upon hypotenuse. The ratio of cos is adjacent upon hypotenuse, and the ratio of tan is opposite upon adjacent. Okay, so we are going to use one of these three ratios in each and every questions. There is nothing apart from these ratios in any of the questions. So let's start. Let's begin. The first question. A circus artist is climbing a 20-meter long rope which is tightly stretched and tied from the top of a vertical pole to the ground. So this is the pole AB and this is the rope AC. So this rope AC is tied at point C on the ground. Okay, BC is the ground level, AB is the pole, AC is the rope. The length of the rope is 20 meter. Find the height of the pole if the angle made by the rope with the ground level is 30 degree. So this rope is making an angle of 30 degree with the ground. Okay, this angle is known as angle of elevation. It is known as angle of elevation. Elevation. So what is angle of elevation? So suppose this is level. I'm sorry, this is not even level. Let me draw a level ground for you. Okay. So suppose this is level ground. Okay. On this level ground, suppose a boy is standing. No need boy, a person, human, anyone standing. But if this person is looking in a straight line, okay, so this is the line of sight. This is known as line of sight. Our general line of sight is along a straight line parallel to the ground. हम लोग जनरली ऐसे ही देखते हैं. हाँ, लेकिन अगर हमें कोई टॉल ऑब्जेक्ट देखना है, सपोज यहाँ पे कोई माउंटेन है और ये बॉय को अब ये माउंटेन के टॉप पे देखना है, तो वो क्या करेगा? वो अपनी आईज को, अपने गेज को ऊपर उठाएगा और वो यहाँ पे देखेगा. ठीक है, so he will have a look at the top of the mountain. So now what has happened, he has elevated his gaze. ठीक है, so this angle theta is known as angle of elevation. Angle of elevation कब बनता है? Angle of elevation तब बनता है जब line of sight ग्राउंड से पैरेलल होती है ओरिजिनली, और उस लाइन ऑफ साइट को ऊपर की तरफ जब शिफ्ट किया जाता है, द गेज, व्हेन द गेज शिफ्ट्स अप, ठीक है, यू गेट एंगल ऑफ एलिवेशन. सो दिस इज द एंगल ऑफ एलिवेशन, थीटा. ठीक है, नाउ सपोज देयर इज अ माउंटेन and a boy, and this is the ground, level ground. Okay, and a boy is standing on the top of this mountain. ठीक है, एंड ही इज लुकिंग स्ट्रेट, सो हिज दिस इज हिज नॉर्मल लाइन ऑफ साइट. But suppose there is a car over here which is approaching the mountain or going away from the mountain or just stationary. This car is over here and he wants to look down towards the car. So what he has to do? He has to lower his gaze. उसकी जो आई साइट है उसको नीचे देखना पड़ेगा, नीचे करनी पड़ेगी. तो लाइन ऑफ साइट से आई साइट जब नीचे जाती है तो उसको क्या बोलते हैं? एंगल ऑफ डिप्रेशन. डिप्रेशन, जो मेंटल डिप्रेशन होता है और ये डिप्रेशन दोनों सेम है, लेकिन डिप्रेशन मतलब यहाँ पे एंगल नीचे की तरफ बना है. लाइन ऑफ साइट से नीचे जब एंगल बनता है तो एंगल ऑफ डिप्रेशन होता है, और लाइन ऑफ साइट से ऊपर की तरफ जब एंगल बनता है तो एंगल ऑफ एलिवेशन होता है. ठीक है, तो ये दो कॉन्सेप्ट है, न्यू कॉन्सेप्ट है, जो वर्ड प्रॉब्लम के साथ एसोसिएटेड होंगे इन दिस पर्टिकुलर चैप्टर. सो वी आर गोइंग टू come across them here and there, okay, in the whole chapter. So please remember them. अगर चाहिए तो ड्रॉ करके भी ले सकते हो. एनीवेज, तो ये जो रोप एंगल ऑफ एलिवेशन बना रहा है, ठीक है, दैट इज 30 डिग्री. इसको हम एंगल ऑफ एलिवेशन ही बोलेंगे. ठीक है, वी हैव टू फाइंड द हाइट ऑफ द पोल. ओके, नाउ इन दिस फिगर, द फिगर इज ऑलरेडी गिवन टू यू. आई वुड लाइक टू आस्क यू अ क्वेश्चन. व्हाट इज थीटा? Theta is 30 degree. With respect to theta, which side you know? With respect to theta, I know the hypotenuse. With respect to theta, which side you want to find? I want to find the opposite side. Okay, so you know the hypotenuse and you have to find the opposite side. That means which ratio you will use? You will use the ratio of sine. Okay, so in triangle ABC, sine theta is equal to opposite upon hypotenuse. Correct? So sine 30 degree is equal to opposite. Opposite is AB upon hypotenuse, which is AC. What is sine 30? It is 1 by 2. What is AB? AB is not known. It is the height of the pole. What is AC? It is 20. So AB becomes 20 by 2, which is 10 meter. AB is 10 meter. Okay, so height of the pole is 10 meter. That's it. That's it. This is it. This is all you need to do in this chapter. Easy? Understood? Let's go ahead. Okay, next question. A tree breaks due to storm and broken part bends so that the top of the tree touches the ground, making an angle of 30 degree with it. Achha, so there is a tree supposed to be like this. Okay, and this tree has been broken. Okay, ये ट्री टूट गया. कहाँ से टूटा? सपोज यहाँ से टूट गया और ये टूट के नीचे गिर गया. तो नीचे गिरेगा तो वी हैव टू मेक इट समथिंग लाइक दिस. है ना, यू टू मेक समथिंग लाइक दिस. तो ये ट्री जो ग्राउंड के साथ एंगल बना रहा है, ठीक है, द एंगल दिस ट्री इज मेकिंग विद द ग्राउंड इज हाउ मच? इट इज 30 डिग्री. ठीक है, द डिस्टेंस बिटवीन द फुट ऑफ द ट्री टू द पॉइंट वेयर द टॉप ऑफ द ट्री टचेस द ग्राउंड इज 8 मीटर. मतलब ये फुट ऑफ द ट्री से ये टॉप ऑफ द ट्री जहां पे ग्राउंड को टच कर रहा है, मतलब ये वाला एंगल, ये वाला डिस्टेंस, ये कितना है? 8 मीटर है. फाइंड द हाइट ऑफ द ट्री, ओरिजिनल हाइट ऑफ द ट्री यू हैव टू फाइंड. ठीक है, अब ये देखो, ये जो डायग्राम है कितना कॉम्प्लिकेटेड है. मैं तुम्हारे लिए एक इजी डायग्राम बताता हूँ तुम्हें, विच यू हैव टू मेक इन दी एग्जाम. ठीक है, सो सी दिस इज द डायग्राम विच वी आर गोइंग टू मेक इन दी एग्जामिनेशन. इसको मैं ऊपर लेके आता हूँ. ठीक है. Now can you see that the original tree is DB? This is the original tree DB. और ये ट्री पॉइंट ए से टूट गया और वो यहाँ पे गिर गया नीचे, 30 डिग्री का एंगल बना रहा है ग्राउंड के साथ, एंड इट्स टॉप, that is point D, is now point C over here. ठीक है. It is touching at a point on the ground 8 meter away from the base of the tree, which is B. So this is the situation. You have to find the height of the tree, which is h1 plus h2. देखो h2 यहाँ पे गिर गया और ये AC बन गया h2, right? So we have to find h1 and h2. That's it. And we have to add it. So we will find the height of the tree. Let's do it. Very easy. So let's see how to do it. Okay, so in triangle ABC, सबसे पहले मैं बोलूंगा कि see, I have been given adjacent side, I want to find opposite. So tan 30 is equal to opposite upon adjacent. Tan 30 is this angle, okay? Tan 30 is 1 by root 3, which is opposite h1 upon adjacent, which is 8. So h1 is equal to 8 by root 3. That is 8 root 3 by 3 meter. Right? So that is h1. Okay? Tan 30. Great. Now what is h2? Again, we have to take the same triangle ABC. In triangle ABC, but now we know the adjacent and we have to find the hypotenuse. We know the adjacent and we have to find the hypotenuse. So cos 30 is equal to adjacent upon hypotenuse. Cos 30 is root 3 by 2, which is equal to adjacent. Adjacent is 8 upon hypotenuse, which is h2. Okay, so h2 will become 8 multiplied by 2 divided by root 3, which is 16 by root 3. This is h2. Okay, so we have found h1 and h2. Now height of the tree is h1 plus h2. Okay, let me write it here. Height of tree is equal to h1 plus h2 h1 is 8 root 3 by 3 plus h2 is 16 by root 3. Okay, so this is root 3, this is 3. So 8 root 3 times root 3 is 8 3s are 24 plus 16. 16 3s are 48 upon 3 root 3. Okay, so 24 plus 48 is 68 plus 4 72. 72 by 3 root 3. So 3 and 72 cuts, we get 24. 24 by root 3. Let me rationalize this. Yes, so if you rationalize this, you get 24 root 3 by 3, and 3 gets cut with 24, so you get 8 root 3. You get 8 root 3. So height of the tree is 8 root 3. And if you want to find the height in decimal points, which you have to actually, so height of the tree becomes, so height of the tree becomes 8 times 1.732, which is let me find the answer and tell you. 8 times 1.732, 13.856 or 13.86 meters. This was the original height of the tree. Okay, let's check the answer. I hope you understood the method, how we apply trigonometry in same triangle twice to find h1 and h2, hypotenuse and opposite side. 13.86. Let's check the answer. 8 root 3. So they have left the answer over here. Now there might be slight contradiction here. In many schools and many boards, teacher wants the final answer in decimal points. But in other schools, teacher says that, oh, it's okay if you leave the final answer in roots. As per me, the final answer must be in the decimal points in this chapter. So I think that you should convert the final answer and express it in decimal points, correct up to 2 decimal places, like how I did it. Okay, so I will consider only that. Whatever your school wants, see, even if you write the answer in decimal points, your school is not going to cut the marks. But yeah, it's possible that if you don't mention your final answer in decimals, the school will cut the marks. Okay, so don't take any risks. Express the final answer in decimals. Okay, next question. Looks like a long question, and let's see uh, how will be the figure. A contractor plans to install 2 slides for the children to play in a park. For the children below the age of 5 years, she prefers to have a slide whose top is at a height of 1.5 meter and is inclined at an angle of 30 degree to the ground. Okay, so let's draw this slide 1 for children below 5 years. uh, let's draw a triangle like this. Okay, so let's name this triangle. Now of course this is right angled over here. Let's name this triangle ABC. uh, the top of this slide is at a height of 1.5 meter. So AB is 1.5 meter and is inclined at an angle of 30 degree to the ground. So this angle is 30 degree. Whereas for elder children, she wants to have a steep slide at a height 3 meter. Whoa, height 3 meter. Steep slide. Something like this. This will be fun. PQR. This PQR is slide number 2. Slide 2. Okay, whose height is 3 meter from the ground and making an angle of 60 degree, making an angle of 60 degree with the ground. Okay, what should be the length of the slide in each case? Okay, so they are just asking the length of AC and the length of PR in each case. Okay, that's very nice. We can easily find it. So in triangle ABC, we have to find the length of the hypotenuse AC. In triangle PQR also, we have to find the length of hypotenuse. So we know this angle, opposite side and the hypotenuse. So in triangle ABC, sine 30 is equal to opposite upon hypotenuse. Sine 30 is 1 by 2. Opposite side is 1.5 meter and hypotenuse is AC. So AC is equal to 1.5 times 2. So AC is equal to 3 meter. In triangle PQR, sine 60 is equal to opposite upon hypotenuse, which is root 3 by 2, is equal to opposite, which is 3 by hypotenuse. We don't know. So hypotenuse PR is 3 times 2 by root 3. Root 3 and 3 cancels. We get root 3. So PR is equal to 2 root 3 meter. Okay, so as I told you earlier that you have to convert the roots into decimals. So what you do is PR is equal to 2 times 1.732 or 3.464, which is 3.5 meter. So the slide for children below 5 years the length of slide will be 3 meters and the slide 2 will have the length of 3.5 meters approximately. Let's check the answers. Yeah, the first one is 3 meter. For elder children, it will be 2 root 3. And I told you 2 root 3 as per me is 3.464 or 3.5 meter, correct up to 2 decimal places. So as I told you, please convert the final answer in decimal points. Okay, great. The angle of elevation of the top of a tower from a point on the ground which is 30 meter away from the foot of the tower is 30 degree. Okay. The angle of elevation of the top of a tower from a point on the ground. Let's say that this AB is the tower which is making 90 degree with the ground. Any tower, any tree, any pole, any building will always make 90 degree with the ground. Okay, so it is all the questions always will involve a right angle triangle. Okay. The angle of elevation of the top of a tower from a point on the ground which is 30 meter away from the foot of the tower. So this is 30 meter and this is the point we are talking about, and the angle of elevation from this point is 30 degree. Find the height of the tower. This is so simple. Okay, so in this figure we have been given the adjacent and we have to find the opposite. So tan 30 is equal to opposite upon adjacent. If you know सो का टोआ, you quickly figure out कि मेरे को adjacent दिया है, opposite ढूंढना है, तो O और A का क्या relation है? tan टोआ. ठीक है? So tan 30 1 by root 3, opposite which is AB and adjacent which is BC. So 1 by root 3 is equal to AB by BC which is 30, and AB is equal to 30 by root 3 which is 30 root 3 by 3 gets cancelled. So AB is equal to 10 root 3. Let's simplify. 10 times 1.732 which is 17.32 meters. So the height of the tower is 17.32 meters, right? Let's go to the next question. First let's check the answer. Absolutely correct. Question number 5. There are approximately 15-16 questions. Okay, a kite is flying at a height of 60 meter above the ground. Okay, so the height, anytime in any question they mention the height, it is always the vertical height. Height cannot be slant. So the height of the kite, let's say kite is flying at point A, point B is vertically below point A at a distance of 60 meter. The string attached to the kite is temporarily tied to a point on the ground. Okay, so this is the kite and let's say this is the point where the string is attached to the ground. The inclination of the string with the ground is 60 degree. That means this is 60 degree angle of elevation. Find the length of the string assuming that there is no slack in the string. That means this string which you see AC, it has no slack. It is tight. Okay, they call it taut also, T-A-U-T, or tight, or without any slack. Okay, so you have to find the length of the string, that is AC, that is the hypotenuse. So what is the relation between hypotenuse and opposite? Of course, sine of 60 degree is equal to opposite upon hypotenuse, which is AB upon AC. Sine 60 is root 3 by 2, which is equal to AB by AC. So AC is equal to 60 times 2 by root 3, which is 120 by root 3. Let's rationalize the denominator. So we get 120 root 3 by 3, which is 40 root 3. 120 root 3 by 3, which is 40 root 3. Okay, so AC is 40 times root 3, which is 1.732. So you can write it as 4 times 17.32 and 4 times 17.32. Let's check the answer. 4 times 17.32, 69.28. 69.28 meters will be the length of the string with which this kite has been tied. Easy. Till now the questions were very simple, very straightforward, single triangle, no complicated figures, simple applications of trigonometry. Let's see how the questions are going to be. 40 root 3, correct. As you can see, all the answers are left in root, but yeah, I will suggest that you have to write the final answer in decimals. A 1.5 meter tall boy is standing at some distance from a 30-meter tall building. Okay, so there is this building which is 30-meter tall, and a boy is standing, 1.5-meter tall boy is standing at some distance from the building. Okay, so let's say AB is the building and CD is the boy. This is 30 meter, this is 1.5 meter. The angle of elevation from his eyes to the top of the building increases from 30 degrees to 60 degrees as he walks towards the building. See, now from this point, this is the line of sight of the boy. And if he gazes up, if he looks up towards the top of the building, then he finds the angle of elevation from this point to be 30 degree. But the boy, what he does, he walks and comes at, let's say, this point. And the names of these 2 points, let me say PQ, angle being 90 degree over here. Now from this point also, this is the line of sight, and the angle of elevation, the angle of elevation is how much? It is 60 degree. Angle of elevation is 60 degree. Okay, so we have to find the distance he walked towards the building, that is QD. We have to find QD. Very interesting question. In normal circumstances, you will not get the answer of this kind of question, but here you will, with the help of trigonometry and little bit of geometry. Okay, so I will name this point as let's say E. Okay, so I will consider two right angle triangles. In all the trigonometric application of trigonometry or heights and distances questions, you need to first figure out how many right angle triangles do you see. So there are two right angle triangles. Triangle AEC and the second right angle triangle is triangle AEP. In triangle AEC, can you find AE? AE is AB minus EB, which is AB minus, you know what is EB equal to? EB is equal to CD. Why? Because if you see closely, EBDC is a rectangle. Okay, so opposite sides of rectangle are equal. So AB is 30 and CD is 1.5. So 30 minus 1.5 is 28.5 meter. Okay, so we have found AE Now, in triangle AEC, we know AE and we have to find EP. EP. I'm sorry. One second. One second. In triangle AEC, we know AE and we have to find EC. EC. Okay. Let's find EC. So EC, if you see this angle 30 degrees, the adjacent side. EC is the adjacent side to this angle 30-degree angle, and AE is opposite. So tan of 30 degree is equal to opposite upon adjacent, which is AE by EC, and tan of 30 is 1 by root 3, which is equal to AE, which is 28.5 upon EC, which is unknown. Okay, so EC is equal to 28.5 multiplied by root 3, which is 1.732. I'm directly going to get the answer of this in decimals. So 28.5 times 1.732, 49.362. So 49.36 meters. Now what is this? This is EC. Now I told you there is one more triangle you can take, AEP. In triangle AEP, we know this angle is 60 degree and we know AE is 28.5. We have already found it. This side, right? So we can find EP. So tan of 60 degree is opposite upon adjacent. Opposite is AE, adjacent is EP. Tan 60 is root 3. AE is 28.5, we found it already, and EP we don't know. So EP is equal to 28.5 divided by root 3. Okay, let's find this. 28.5 divided by 1.732. Okay, so on division you get 16.45. 16.45 meters. Okay, so this is 16.45, and the whole thing from E to C, actually I should not write it to make a mess. Okay, the whole thing from E to C is 49.36. We have to find the distance he walked, the distance he walked towards the building, towards the building. Okay, that is the distance he covered from point D to point Q. That is QD, which is equal to CP. So basically we have to find CP. So CP is equal to CE or EC minus EP. So what is CE? 49.36. What is EP? EP is 16.45. Okay, so 49.36 minus 16.45, it's 32.91. So this boy, he walked towards the tower for 32.91 meters and reached the position PQ. So this is one of the type of questions which is little bit complicated because there are two triangles involved. Okay, and in both the triangles you had to apply trigonometry, so it becomes little lengthy, but yeah, it's not difficult. Let's check the answer first. Calculations are a little tricky here. Let's check the answer. Just a moment. Okay, so we are getting 19 root 3. Let me just check the answer. 19 root 3. 19 times 1.732. 32.91. That's what the answer we were also getting. 32.91. Absolutely correct. Right? So my method is simpler. It is easier and you can easily get the answer. Please note down the technique, the diagram, the steps. Note it down properly. Okay, let's move ahead. We are getting correct answer. Let's go ahead to the next question. Question number 7. From a point on the ground, the angles of elevation of the bottom and top of a transmission tower, okay, fixed at the top of 20-meter high building. Okay, now see what is happening. There is a 20-meter high building named, let's say, AB, and on the top of the building there is a transmission tower. जैसे अपने बिल्डिंग्स पे मोबाइल के टावर होते हैं ना, वैसे ही. ठीक है. सो ये ट्रांसमिशन टावर है यहाँ पे, ब्लू में बनाया मैंने. आई एम गोइंग टू नेम दिस पॉइंट एज सी. ठीक है. फ्रॉम अ पॉइंट ऑन द ग्राउंड द एंगल्स ऑफ एलिवेशन of the bottom and top of transmission tower fixed at the point 20-meter high, fixed at the top of 20-meter high building are 45 degree and 60 degrees. So if I look here, this is making 45 degree, but if I look at the top of the transmission tower, that is at this point, this angle which is being made, let's say from here to here, it is 60 degree, 45 degree and 60 degree. Okay, find the height of the tower. Height of the tower means which height they want to find? Height of the transmission tower, that is AC. We have to find the height AC. So first question I would like to ask, that do you know what is let's say this point is D, what is BD? We don't know what is BD, so first we have to find BD and then think ahead. Okay, so this is 90 degree. Now first we are going to consider triangle ABD. Okay, we are going to consider triangle ABD. In triangle ABD, tan 45. Why tan? Because I'm concerned with adjacent and opposite. So tan 45 is equal to opposite upon adjacent. First I want to find BD, right? So tan 45 is 1, AB is 20 upon BD. So BD is also 20 meter. Doesn't look like in the question AB and BD are equal. Doesn't look like in the figure, but that doesn't matter. Okay, now in triangle DBC, can you see triangle DBC? In triangle DBC, tan 60 is equal to opposite upon adjacent. Tan 60 is root 3. Opposite of 60 degree is BC and adjacent is BD. So BC we don't know. Okay, and BD is 20. So BC is equal to 20 root 3 meters. That is 20 times 1.732. That is 17.32 meters. Hey, 17.32 times 2. That is 34.64 meters. That is BC. Okay, so we got BC. Now we don't have to find BC, we have to find AC. And if you look at the figure closely, AC is equal to BC minus AB. What is BC? 34.64 minus what is AB? AB is 20. So 34.64 minus 20 is 14.64 meters, which is the height of the transmission tower, which is placed above the building. Okay, let's check the answer. Very easy, right? But only thing is there are two triangles. So all the little challenging questions will have two triangles in them in which you have to apply trigonometry and get the answer. 14.64 meter. Let's check the answer. Yes, absolutely correct. Let's go to the next question. A statue 1.6 meter tall stands on the top of a pedestal. Okay, so there is a Pedestal means a platform kind of a. Okay, so this is a, let's say this is a pedestal, and on the top of this pedestal there is a statue. So statue is AB, pedestal is BC, and this angle is 90 degree. This point is C. I'm not read the question, but yeah, I can figure out के क्या करना होगा आगे, ठीक है? Okay, statue 1.6 meter tall stands on the top of a pedestal from a point on the ground. The angle of elevation of the top of the statue is 60 degree. Acha. So this angle is 60 degree. And from the same point, the angle of elevation of the top of the pedestal. Oh, top of the pedestal is over here. So if you connect this point with this point, let me make a proper line with another color. Here the angle of elevation is how much? Here the angle of elevation is 45 degree. Find the height of the pedestal. Height of the pedestal is BC. You have to find BC. Alright, so this seems little challenging because we don't know CD also, we don't know BC, we just know AB. And so this is little trickier than the previous question. Okay, let's see how to do it. So first we are going to talk about triangle BCD. In triangle BCD, tan 45 is equal to opposite upon adjacent. Tan 45 is 1. Opposite is BC. Adjacent is CD. Okay. So we can say that without any confusion that BC is equal to CD. BC is equal to CD. Okay. So let BC is equal to CD is equal to X meter. BC is equal to CD is equal to X meter. We'll take it as X. This as X and this as X. We have proved it, right? So now in triangle ACD, do you see the bigger triangle ACD? In triangle ACD, tan of 60 is equal to opposite upon adjacent. Tan 60 is root 3. Opposite is 1.6 plus X upon adjacent is X. Right? Opposite is AC, which is 1.6 plus X, and adjacent is CD, which is X. Shift X to the other side. Root 3 times X is equal to 1.6 plus X. Let's solve this. So root 3x minus x is equal to 1.6. We'll take out x common. Root 3 minus 1 is equal to 1.6. So x times, see this is 1.732. Root 3 minus 1 is equal to 1.6. So x times 0.732 is equal to 1.6. So x is equal to 1.6 by 0.732. So x is equal to 1.6 divided by 0.732. 2.19. Yeah, you can get it as 2.19 meters. So this is the height of the pedestal. Pedestal is the platform, okay, whose height is 2.19 meters approximately. All right, great. Let's check the answer. 2.20, 2.19. Yeah, so approximately the same answer. I rounded off and I got it for you. Okay, so my method, if you see, it is very concise, very small, very easy to understand. Okay, let's go to the next question. This was question number 8. Nice. The angle of elevation of the top of a building from the foot of the tower is 30 degree, and the angle of elevation of the top of the tower from the foot of the building is 60 degree. Okay, so there is one building and there is one tower, and both are having different heights. Okay, great. Which is higher and which is lower, we don't know. So you see, the angle of elevation of the top of the building is 30 degree, and the angle of elevation of top of the tower is 60 degree. So definitely tower is higher than the building, right? So let's say this is the tower and this is the building. This is the ground. Both are making 90 degree with the ground. AB is the tower. CD is the building. Now what they are saying is angle of elevation of the top of a building from the foot of the tower is 30 degree. So this is the foot of the tower, and if you join it with the top of the building, the angle of elevation is 30 degree, and the angle of elevation from the top of the tower from the foot of the building is 60 degrees. So if you join this is going to be how much? 60 degree. Makes sense? Diagram is also perfect. Okay, great. If the tower is 50-meter high, tower is 50-meter high, find the height of the building. Great, very easy. Just focus on which triangles I'm taking. Okay, in triangle ABD, in triangle ABD, in triangle ABD, see, if you see triangle ABD, I think I should draw it with another color. So I'm just highlighting on this so that you see both the triangles in separately, otherwise they are overlapping triangles and you can get confused. So triangle ABD, which is highlighted with red color, angle ADB is 60 degree, and we are concerned with opposite, that is AB, and adjacent, that is BD. So tan 60 is equal to opposite upon adjacent. So tan 60 is root 3, opposite of root 3 is AB, opposite of 60 degrees AB, and adjacent of 60 degrees BD. So root 3 is equal to AB, which is 50, by BD, which we don't know. So BD is equal to 50 by root 3 meter. BD is equal to 50 by root 3 meter. I'm not going to bring it in decimal points because BD is not what I require. BD is just intermediate answer. Okay, I have to find CD, so I have to consider triangle CBD. In triangle CBD, again with respect to this 30 degree, I have to find the opposite side and I know the adjacent side. So tan 30 degree is equal to opposite upon adjacent. Tan 30 is 1 by root 3. Opposite is CD. Adjacent is BD. So 1 by root 3 is equal to CD by BD. BD is 50 root 3. Okay. So CD is equal to this is I don't know, this is really strange. One second. Tan 30 is 1 by root 3, which is opposite upon adjacent. Opposite is CD, adjacent is BD. Okay. So we are getting 50 root 3 by root 3, which is 50 meter. How is this possible? There is some issue. Let me just figure out. Okay, I found my mistake. That was a really silly mistake I made. BD is not 50 root 3. It is 50 by root 3. This is 50 by root 3. By mistake I wrote it as 50 root 3. So this is 50 by root 3, which will go in the numerator on the other side. Okay, so CD is equal to 50 by root 3 the whole upon root 3. So CD is equal to 50 by 3. Okay, CD is equal to 50 by 3. 50 divided by 3, which is 16.67 meter. 16.67 meter. So height of the building is 16.67 meter. Let's check the answer if we are getting correct. 16.70 they have just rounded off, and we have rounded off to correct up to 2 decimal places. No problem. Okay, so this question I have solved it for a student uh, in a live class, because that student had examination in the school. So for solving her doubt, I have solved this question. So I'm going to attach this particular question, and I think one more question, one or two more questions I'm going to attach a little later. Okay, so that is end of the video. So question number 10, keep it for pending as of now. You will find it at the end of the video. Okay, let me see. Oh yeah, this one I have not done. Question number 11, let's try this one. A TV tower stands vertically on a bank of a canal. Okay, so there is a canal, and on one edge, or you can say bank of the canal, a TV tower stands vertically. From a point on the other bank directly opposite to the tower, the angle of elevation of the top of the tower is 60 degree. Okay, so do you see that this is the canal? BC is the canal. B is the foot of the TV tower. C is the other end of the canal. C is the other end of the canal. From C, the top of the tower makes an angle of elevation of 60 degree. Okay. From a point 20 meter away from this point C. So if you move 20 meter backwards from point C, the angle of elevation from the top of the tower changes to 30 degree. Find the height of the tower and the width of the canal. So you have to find two things. Two things are missing. H, height of the tower, X, width of the canal. Very nice question. Great. So let's first find the relation between H and X. To find a relation between H and X, we'll take triangle ABC. See, this is definitely 90 degree. Okay. So in triangle ABC, tan of 60 degree is equal to opposite upon adjacent. Now you see that always, or most of the time, we get the relationship of tan. So tan 60 is opposite upon adjacent. Tan 60 is root 3. Opposite is AB and adjacent is BC. So root 3 is equal to AB, which is H, upon BC, which is X. So H is equal to root 3 times X meters. H is equal to root 3 times X meters. Okay. Now you don't get any answers from here, from this statement, but this will be useful in the next calculation, next part of the calculation. So next you have to take triangle ABD. In triangle ABD, tan 30 degree is equal to opposite upon adjacent. Right? Tan 30 now I'm taking. So what is tan 30? 1 by root 3. What is opposite? Opposite is AB again. And what is adjacent? Adjacent is BD. So 1 by root 3 is equal to AB, which is H, upon BD, which is 20 plus X. Right? Now what is H? H is root 3 times X. Let's put the value of H. So 1 by root 3 is equal to root 3x upon 20 plus x. Let's cross multiply. 20 plus x is equal to root 3x times root 3. So 20 plus x is equal to 3x. So 20 is equal to 3x minus x, or 2x is equal to 20, or x is equal to 10 meter. So x is equal to 20 by 2, which is 10 meters. Okay, so we got the value of x. What is x? X is the width of the canal. Now we can find the value of h also. Therefore, h is equal to height of the tower, which is equal to root 3 times x, which is 10. That is 1.732 times 10. That is 17.32 meters. That is height of the tower. Simple. Right? So, yes, little complicated question again, because you have two triangles in which you applied trigonometry and found the missing values. Let's check the answer. Okay, so the height of the tower is 17.32 meter and width of canal is 10 meter. Absolutely correct. Let's go to the next question. Okay, I think, let me check. Okay, so I had left question number 10th earlier. This question is also done by me, which will be, you will find this question at the end of the video. Okay, so let's go to the next question, question number 13th. Nice question. Question number 13th. Okay, as observed from the top of a 75-meter high lighthouse from the sea level, the angles of depression of two ships are 30 degrees and 45 degrees. Now, if you see in this figure, CD or DC is the lighthouse whose height is 75 meter. 75 meter high lighthouse. Okay, now somebody is standing at the top of the lighthouse, and this is the normal horizontal line of sight, but this person is looking below, looking down, so he is actually getting two angles of depressions. So what he is looking at, he is looking at two ships at points A and point B. So when he's looking at point A, the angle of depression is 30 degree, and when he's looking at point B, the angle of depression is 45 degree. Okay, now you would wonder that how come this angle is 30 and 45? Yes, because if you see, this is the horizontal line of sight. This is the horizontal line of sight which is parallel with the ground level or sea level or whatever you call it. Okay, so if these two are parallel lines, ED and AC are parallel lines, then we can say that angle EDA and angle DAC are alternate interior angles. That's why this angle is 30. And angle EDB and angle DBC are also alternate interior angles. That's why this angle DBC is 45 degrees. Okay, so now we are no more concerned with these angles of depressions. We have calculated their counterparts on the sea level or ground level. So we can directly take triangles DBC and ACD respectively and calculate whatever is required. Okay, so these are two ships A and B. If one ship is exactly behind the other on the same side of the lighthouse, find the distance between the two ships. Distance between the two ships is x meters. We have to find x. But we don't even know the distance of the second ship from the base of the lighthouse. So that's why we have taken as, they have taken it as y. If you don't take it as y, there is no issue. Okay, so definitely you have to consider two right angle triangles. That's the first thing how you start with. Okay, so in triangle BDC, that's the first right angle triangle. In triangle BDC, tan 45 degree is equal to opposite upon adjacent. So tan 45 is 1, opposite is DC, and adjacent is BC. So DC is 75 and BC we don't know. They have taken it as Y. If you don't take it as Y, it's okay. So BC is also equal to 75 meter. Okay, so this is 75 meter. Great. Okay, now you have to take triangle ACD. So in triangle ACD, tan 30 degree, tan 30 degree is equal to opposite upon adjacent. Tan 30 is 1 by root 3. Opposite of 30 degree is DC and adjacent is AC. Okay, so 1 by root 3 is equal to DC, which is DC is 75, don't forget. And AC is AB plus BC, that is X plus 75. Did you understand? AC is AB plus BC, AB is X, and BC we have already found 75. So X plus 75 is equal to 75 root 3. Okay, so X is equal to 75 root 3 minus 75. So X is equal to 75 bracket root 3 minus 1. So X is equal to 75 times, see, root 3 is 1.732 minus 1, that is 0.732. So let's find the value of X. See, X is what you need, the distance between two ships. Okay, let's find the value of X. 75 times 0.732, 75 times 0.732 is 54.9 meters. 54.9 meters. Okay, that's the distance between two ships. Let's check the answer. Did you understand the figure and everything? Good. 54.9 meters. Right? So easy question, right? But yeah, only thing, angle of depression, little new thing for you, but not at all difficult. Let's go to the next question. Next question is, a 1.2 meter tall girl spots a balloon moving with wind in a horizontal line at a height of 88.2 meter from the ground. See, the height of the balloon from the ground is constant. It is 88.2 meter over here and 88.2 meter over here. Okay, so height of the balloon is constant. So this balloon is not stationary. It is at a height of 88.2 meter from the ground, okay, and it is moving in a straight line. Okay, so the balloon is moving like this horizontally, but at a height of 88.2 meter from the ground. This is the height from the ground. Okay, okay, the angle of elevation of the balloon from the eyes of the girl at any instance is 60 degree. After some time, the angle of elevation changes to 30 degree, reduces to 30 degree. Okay, so initially the balloon was here at point A, let's say. This is point A, initial position of the balloon. Final position of the balloon is point B, where the angle of elevation reduces to 30 degree. Find the distance traveled by the balloon during the time interval. Now time interval is not known. We have to find the distance AB. Okay, let's name few triangles which I can see over here. This is point C, D, E. Okay, so this is what we know about. Now, one more thing I would like to tell, that the height A, and let me name these 2 points at P and Q. AP and BQ is 88.2. But what is DP? DP is the height of the girl, which is 1.2 meter. CQ 1.2 meter. So actually the height of the balloon from the line of sight of the girl, that is EC, who is the girl is 1.2 meter long. So that is 88.2 minus 1.2. That is 87 meter. Okay, so this will be 87 meter, not 88.2, 87 meter. 88.2 is BQ, but BC is 87 meter. Remember that. Okay, great. So we have to find the distance moved by the balloon from A to B, and AB will be equal to CD. Don't forget that. Okay, this is 90 degree. This is 90 degree. Okay, let's consider few triangles now. In triangle EBC, do you see triangle EBC? So in triangle EBC, angle BEC is equal to 30 degree. Okay, so tan of 30 is equal to opposite upon adjacent. Opposite is BC, adjacent is EC. So tan 30 is 1 by root 3. BC is 87 and EC is not known. So EC is equal to 87 by root 3 meters. EC is 87 by root 3. We don't have to find EC. Okay. Another triangle we'll consider, triangle AED. Do you see triangle AED? In triangle AED, we'll take tan of angle AED, which is 60 degree, which is opposite upon adjacent. Tan 60 is root 3. Opposite is AD, which is 87 upon adjacent. Adjacent is ED. So ED is equal to, hey, so I made a mistake here. See, this is 87 root 3, not 87 by root 3, 87 root 3 meters. Okay, and this will be 87 by root 3 meters, ED. So we found EC and ED. Now we want AB, which is equal to CD. So CD is equal to EC minus ED. Okay, EC is 87 root 3 minus ED is 87 by root 3, which is, if you take LCM, it becomes 87 times 3 minus 87, the whole upon root 3. Okay, let's calculate that. So 87 times 3 is 261. 261 minus 87 is 174. 174 divided by root 3. That is divided by 1.732. It gives approximately 100.5 meters. 100.5 meters. So 100.5 meters is the distance traveled by the balloon during this time interval, that is from A to B or C to D. The distance is 100.5 meters. Okay, so let's check the answer. Okay, so they are getting 101.9, which is little bit different from our answer. Let's see what might have caused this calculation difference. Okay, so I found the mistake of this solution. So here they have clearly mentioned that the height of the balloon is 88.2 meter from the ground. You see, height of the balloon is 88.2 meter from the ground they are mentioning, and height of the girl is 1.2 meter. And here what they have taken is, in the diagram also you can see height of the balloon is 88.2 meter from the level of the girl, and that is absolutely wrong. So that's why they are getting little different answer, 101.9, and we are getting a little different answer, that is 100.5. so my answer is accurate in this case. Still, I want you to check what is the answer in the book. If the answer does not match mine, then I have to resolve it. But I think my method and answer both are correct. Okay, great. Let's do the next question. A straight highway leads to the foot of a tower. Okay, straight highway. So this is the highway which leads to the foot of the tower. A man standing at the top of the tower. So here there is a man. A man is standing on the top of the tower. See, this is the tower, DC. You see DC? Yeah, so here there is a man who is standing and, oh, sorry. Yeah. A man standing at the top of the tower observes a car at an angle of depression of 30 degree. So a car is over here and man is over here. He is looking at the car. He is observing the car. And as you can understand, this is the line of sight of the man. And when he looks down from the tower, he makes an angle of 30 degree with the line of sight. So angle of depression is 30 degree when the car is over here. And because these two angles are alternate interior angles, this angle also becomes 30 degree. You see? Okay. Now this car is not stationary. This car is traveling towards the foot of the tower. This car is traveling towards the foot of the tower. It is coming towards the tower. Okay. So after uh, a car which is approaching the foot of the tower with a uniform speed, 6 seconds later, after 6 seconds, the angle of depression of the car is found to be 60 degree. So after 6 seconds, the car reaches this point, point B. Okay, now if the man is looking down at the car, he is making an angle of 60 degree with the line of sight. So this angle also becomes 60 degree, alternate interior angle. Find the time taken by the car to reach the foot of the tower from this point. So from this point, which point are they taking? Uh, 6 seconds later, the angle of depression of the car is found to be 60 degree. Find the time taken by the car to reach the foot of the tower from this point. This point means from point B. So how much time will the car take traveling from point B to point C? That's what we have to find out. Okay, so I think in this question, they have not given the height of the tower. They have not given anything actually. They have just given that the car takes 6 seconds to reach from point A to point B. That is to for the angle of depression to change from 30 degree to 60 degree, it takes 6 seconds. Okay, so let's write some statements. I'm not going to take it as 6V or NV or whatever. I'm going to do it my way. Okay, so little different, but please pay attention, you will understand. Let the distance covered by the car in first 6 seconds be x meters. Okay, so this is x meters. I'm going to take this distance as x meters. Okay, great. The distance covered by the car in first 6 seconds be x meters. Okay. Therefore, speed of car is equal to distance upon time. Distance is x, time is 6. X by 6 meter per second. See, the car has got uniform speed. So we took the speed of the car as x by 6 meter per second because the distance covered is x meter and the time taken is 6 seconds. So x by 6 meter per second will be the speed of the car. Great. Now, if the car continues to travel with the same speed, the remaining distance, now we don't know the remaining distance, but we can find in terms of h, right? Let's take triangle DBC. So in triangle DBC, tan 60 degree is equal to opposite upon adjacent. Opposite is DC, adjacent is BC. Tan 60 is root 3. DC is H. BC we don't know. So BC is equal to H by root 3. Okay, so this is H by root 3 meters. h by root 3 meters. Great. Uh, Again, we'll take triangle ACD. In triangle ACD, tan 30 degree is equal to opposite upon adjacent. Opposite is DC, adjacent is AC. Tan 30 is 1 by root 3, DC is H, and AC is x plus H by root 3. X plus H by root 3. This is little complicated, but it's going to sort out, don't worry. So we'll cross multiply. X plus H by root 3 is equal to H root 3, or root 3 times H. Root 3 times H. Right? Okay, great. So X is equal to, see, we are going to find the value of X in terms of H. So root 3H minus H by root 3. Okay, on taking LCM we get 3H minus H by root 3. So X is equal to 2H by root 3. Right, so this is the value of X, that is 2H by root 3 meters. Okay, now we got the value of X in terms of H, that is height of the tower. We have to find the time taken by the car to reach the foot of the tower from this point. Okay, so this is going to be easy. I'll tell you how. uh, See, the car is traveling with the speed of x by 6 meter per second. That is, in 1 second the car is covering a distance of x by 6 meters. Okay, now I want to find what is the distance from B to C in terms of h. In terms of h. Okay, so h by root 3. Therefore, h by root 3 is equal to, this 2 goes on the other side, so we get x by 2 meters. Okay, so see, distance and time. I'm going to use unitary method. Please pay attention how I'm using. So if the car travels x meters in 6 seconds, what will be the time taken for the car to travel x by 2 meters? Very easy. X by 2 multiplied by 6 upon x, which is 3 seconds. So car will take further 3 seconds to reach the base of the tower. Find the time taken by the car to reach the foot of the tower from this point. It will be 3 seconds. Let's check the answer. Yeah, so their method is very complicated. They have NV, 6V. I don't know how they have done it. But if you check out my method, I have just taken two variables. One is uh, X, that is the distance covered in first 6 seconds, and other is H, which is height of the tower. And everything I have expressed in terms of X and H, and I simply got the distance covered from point B to point C in terms of X, and I use unitary method to find the time, which is 3 seconds. So from going from B to C, the car will take 3 seconds. Okay, now the last question, as I told you earlier, there are a couple of questions which I will attach the video after this. So after this you will find the question number 10, 12 and 16 solved by me for a student who had doubts in it. In a live class I have solved them, so you will find the video of the solutions of those questions after this. Please have a look at them, and please note down all the questions, understand all the methods which I have used. I highly recommend it. Okay, so I'm just going to stop talking and attach that video after this, and then I'm going to stop this video. Okay, I'm going to stop this video is going to stop out after this. The chapter is over, then I'm going to provide you homework. So bye bye for now. Okay, so this chapter is called heights and distances. or applications of trigonometry. The first thing is that after reading the question, you should be able to draw the diagram. If you're able to draw the diagram properly, then I think half the job is done. Then only calculation and application of formula remains. That's not a big deal, that we can deal with. But main thing is drawing the diagram properly. So for that, we'll understand the question, draw the diagram, and then we'll think about that, what has to be found or how we have to apply the formula. Two poles of equal heights are standing opposite to each other on either side of the road. Now this first statement, it gives us a clear idea about what is the situation. Okay, so I'm going to draw two poles on either side of the road. Now pole, building, tower, these all things are always, tree, these all things are always considered to be perpendicular to the ground. So always remember that their angle which they will make with the ground will be 90 degree.
Yes, sir.
Okay, so this is one pole of equal heights, huh? Their heights are equal. Okay, this is one pole. Let me draw another pole. Okay, so let's say that these are the two poles of equal heights standing on opposite side of the road, or opposite to each other on either side of the road, which is 80-meter wide. So this road is 80-meter wide. From a point between them on the road, now there is a point somewhere in between. We don't know where, but they've given a hint. From a point between them on the road, the angle of elevation of the top of the poles are 60 degree and 30 degree. So there is a point somewhere over here. Suppose the point is over here, point P. So if you join this point P to the top of this pole AB, the angle of elevation which is becoming over here is 60 degree. You know what is angle of elevation, right?
Yes, sir.
So basically, when you are looking straight, and that is parallel, your eyesight is parallel to the ground, and then when you have to look up, what you are doing is you are moving your neck up, you are moving your eyesight up, so you are elevating your eyesight.
Yes, sir.
So that way, if you see, your eyesight goes in this direction, it elevates. That's why this angle which we are seeing over here is the angle of elevation. So angle of elevation of one of the tower is 60 degree, and the angle of elevation of the other tower, I'm sorry, angle of elevation of the other tower is 30 degree. This one is 30 degree. Let's say this is CD. So from point P, if you're looking at the top of tower AB, you have to elevate your gaze or your eyesight by 60 degree with respect to the ground. And from
Yes,
point
sir.
P, if you're looking at the top of the tower CD, you have to elevate your gaze by 30 degree. That's the angle of elevations. Okay, so this is the information they have given. One more information which I did not mention, that this is 90 degree. Great. Find the height of the poles and the distance of the point from the poles. Very nice question. So this is 80-meter. Let me just mention it properly. This B to D, BD, is 80-meter. Okay, the height is not known. We have to find the height, so we'll take it as H. Okay.
Okay.
Now what we'll do is, there is a very interesting thing we can do in this. In this triangle APB, we'll take the small triangle first. In this triangle APB, we know that AB is H, and we know this angle opposite to AB is 60 degree. So if we apply trigonometry, if we represent side BP in terms of AB with using trigonometry, then what will happen is we'll find BP in terms of H. We'll find BP in terms of H, and that will be easy. So what we have to relate, just pay attention, we have to relate BP, we have to relate H, and we have to relate this angle 60 degree. Now with respect to this angle 60 degree, BP is adjacent, right?
Yes,
BP is
sir.
adjacent and H is opposite. So can you tell me, Upasana, which ratio relates the adjacent to the opposite?
So, cos.
No, remember SOHCAHTOA. SOHCAHTOA. So ka toa. S means sine. Sine is opposite upon hypotenuse. C means cos. Cos is adjacent upon hypotenuse. Here you said cos. Hypotenuse is not
Yes,
at
sir.
all in question. And tan is opposite upon adjacent. So opposite and adjacent. So always in trigonometry, na, we'll be having either tan or cos. Either tan,
Oh,
either tan or no, only tan actually. Mostly tan. Yeah. So uh, in see how to write in triangle ABP, tan of angle B, sorry, tan of angle P, tan P is opposite upon adjacent. Now angle P is 60 degree, opposite is AB, and adjacent is BP. Tan 60 is root 3, AB is H, and BP we don't know. So we get BP as, if we shift BP to the other side, root 3 will come over here. And what do we have here, Upasana?
height and root
H.
3.
Yeah, what expression should I write over here? BP is equal to root 3 is equal to H by BP. So BP is equal to,
H by root 3.
very good, H by root 3. Okay. So we found BP in terms of H. But that's not all. You have to do the same thing in the other triangle. So in triangle CPD, again I have H over here, and I want to find this PD side in terms of H. So this is my angle which I will take because I know this angle only. This is the angle. This is the side with respect to which I want to represent this side. So I want a relation between opposite and adjacent. So which trigonometric ratio will I use?
Tan.
Tan. Tan of P. But this time P is this angle, okay? Don't get confused with P because point P is common to both the triangles. So this time
Yes.
tan P is this angle in triangle CPD. So you can also write it as tan of angle CPD. It is actually little confusing. So you can write tan of angle CPD is equal to opposite upon adjacent, that is tan of 30 is equal to opposite is CD upon adjacent is PD. Tan 30 is 1 by root 3. CD is H. PD, we don't know PD. So can you tell me how much PD will be? How to find
H
out?
into root 3.
H root 3. Yeah, root 3H. Anything. Okay. So
Yes.
we have found BP and PD. So our work, our job is, like you can say, mostly done. See, BP plus PD is equal to BD, right? We know the
Yes.
value of BP, H by root 3. We know the value of PD, H root 3. is equal to BD, which is 80. BD is 80, yeah. So if you take LCM, this will become H plus H into root 3 times root 3 is 3. So 3H actually, I should not write like this. H plus 3H by root 3 is equal to 80. And on simplifying, you get 4H upon root 3 is equal to 80. So H is equal to 80 times root 3 by 4. So we get 20 root 3. So 20 times 1.732. I'm sure you are aware that you have to put the value of root 3 correct up to 3 decimal places. And then
Yes.
17.32 times 2, that is 34.64 meter. This is the height of the tower, any of the tower A, B and C, D. Also, you have to find the distance of point P from both the towers. Now we know that BP is H by root 3 and PD is H root 3. So what you will do, you will substitute the value of H.
H.
See,
Yes, sir.
don't substitute this value 34.64. We also have a value in root, which is 20 root 3. Substitute this value in over here and over here. So if you substitute 20 root 3 over here, you get 20 meter, and here you get 80 minus 20, which is 60 meter. So the point P is 20 meter away from tower AB and 60 meter away from tower CD.
Yes. Okay.
Understood?
Yes, sir.
Yeah, great. So next doubt is 12th, right?
Yes, sir.
12th, okay. From a top of a 7-meter high building. 7-meter high. Is that even a height? Can a building be 7-meter high? 7 meter is very small. Eh?
Yes, sir.
Okay. From the top of a this miniature 7-meter high building, the angle of elevation of the top of a cable tower is 60 degree, and the angle of depression of its foot is 45 degree. Okay, good. Suppose, hmm, एक minute. Suppose CD is that cable tower and AB is the 7-meter high building. Now, if somebody stands on the top of building AB, the line of sight will be along this line. He or she would be looking straight in this path. Okay, and this point we can take it as E. So DE also becomes 7 meter, because we know that building, cable tower, they all are, making 90 degree with the ground, and of course this
Yes.
line AE will be parallel to BD, because we'll always gaze parallel to the floor. So this AEDB is a rectangle. We know everything about this. Okay. Now they have given the angle of elevation of the top of the cable tower from the top of the building. Okay. So here, from here, if you join a line like this, you get an angle of elevation which is equal to 60 degree. And if you drop down another line to the bottom of that cable tower from the top of the building, you get angle of depression as 45 degree. This is 45 degree. So angle of depression is one more interesting concept. So whenever you are having a straight gaze parallel to the floor, and then if you want to look down upon something, if you want to look down, and you will move your gaze with your neck down, what you're doing is you're depressing your gaze, you're depressing your eyesight. So that depressing your eyesight or looking down is forming this angle of depression, which is 45 degree. So when you are
Yes.
looking at the bottom of the cable tower, you are depressing your eyesight by 45 degree. But when you are looking at the top of the cable tower, you are raising or elevating your eyesight by 60 degree. So that's why these two angles over here. Now, quickly, without any delay, you should be able to know that if angle EAD is 45 degree, angle ADB will also be 45 degree. Why? Because they are alternate interior angles.
Yes, sir.
है ना? तो ये तो लिख ही देना, मतलब you don't have to wait कि ये बाद में कर लेंगे, नहीं, पहले ही लिख दो डायग्राम बनाने के साथ ही.
Okay, sir.
Okay. Now what they are asking is the height of the tower. So first what we'll do is we'll use this triangle ABD, and we'll find this distance BD, the distance between this building and the tower. That's very easy, because if I want to find this distance, and if I know this, again, see, if you notice, this is opposite and this is adjacent.
Yes,
So
sir. Tab again.
tan 45 is equal to opposite upon adjacent, which is AB upon BD. Can you tell me the value of tan 45?
Uh,
It's 1. Tan
yes.
45 is 1. AB is 7 meter and BD we don't know. So BD is equal to 7 meter. Now this looks longer than AB, I know that. Because I didn't know ना, मैंने जब डायग्राम बनाया तो I didn't know कि ये लंबा होगा, ये इक्वल होगा, क्या होगा. तो मैंने तो बना दिया इसको. ठीक है. सो इट
Okay.
डजेंट मैटर यार, डायग्राम में ऐसा इक्वल, मतलब जितना मेजर है उतना दिखना जरूरी नहीं है. डायग्राम इज जस्ट फॉर आवर परसेप्शन. सो दिस इज 7 मीटर. सी नाउ वी नो दैट AEDB इज अ रेक्टेंगल. पहले ही मैंने बात की थी इसके बारे में. सो ऑपोजिट साइड्स ऑफ रेक्टेंगल आर इक्वल. So if this is 7 meter, AE would also be 7 meter. Correct?
Yes, sir.
Yeah. Now I'm going to take a triangle which actually does not exist in between these two towers. It's a hypothetical. No triangle exists, but this triangle I'm going to consider. The triangle I just highlighted. Triangle AEC. You know why I'm going to take this triangle? Because I know the base AE 7 meter. I don't know this side, right?
Yes, sir.
Why I'm finding CE? Because if I find CE, I already know DE. If I add them up,
Yes.
I get the length of the height of the tower.
Yes.
So in triangle AEC, in triangle AEC, we have this angle, opposite side, adjacent side, again tan of 60 is equal. Now you know how to relate these sides and angles, ना? कि अगर मेरे को ये
Yes,
ढूंढना
sir.
है, ये दिया है, तो विथ रिस्पेक्ट टू दिस एंगल ये क्या है? ऑपोजिट है. ये क्या है? एडजेसेंट है. ऑपोजिट एडजेसेंट
Mm.
मतलब tan. ये तुरंत
Mm.
तुम्हारे दिमाग में आना चाहिए. सो tan 60 हो जाएगा √3, and CE we don't know. AE is 7, so CE is 7 √3, and we want to find CD. CD is CE plus ED, which is 7 √3 plus 7. 7 को कॉमन ले लो. √3 plus 1, 7 यहाँ पे हो जाएगा 1.732 plus 1. 7 multiplied by 2.732. Just multiply, get the answer. In meters, you will find the answers. Around 15 meters, maybe 15 or 16, something like that. 15 point something. Okay?
Okay, sir. Yes, sir.
Great. So that was 10th and 12th. Next out is 16th.
Yes, sir.
Okay. Let's see what is 16th. If I draw the diagram for you, you have to solve the question for me. If
Okay,
it
sir.
is not very difficult. If it is complicated, then definitely I'll help you out. But if it is
Mm,
not, then
I think it is somewhat similar only.
okay. There's just one exercise na, in this.
Yes, sir. Only one.
Only one, yeah. It's a small chapter. I'm just going to cover it in few days. Like after some days, I think I'll cover it. We have finished how many chapters in maths? We have finished 9 chapters. Because I did coordinate geometry, that was 7th chapter. 8th chapter
Mm,
is trigonometry, which we have already done. Probability is done. So 9
yes.
chapters are done. Total 16 chapters are there, na?
Uh,
Yeah,
15, I think. Yeah.
16 or 15, yeah. So good, we are going good. Only physics we are a little behind because we have not started with uh,
Refresh.
refraction and reflection, because I
Yes.
feel that we need some time to do that. Like it needs to be done properly. So
Yes,
I
sir.
will do that, don't worry. Okay.
It is
Chalo.
a little confusing chapter, but it's easy.
Yeah, yeah. Reflection is easy. Refraction, refractive index, and all that's little technical.
Yes.
Okay, let's do the last one. The angles of elevation of top of a tower from 2 points at a distance of 4 meter and 9 meter from the base of the tower. Okay, the angle of elevation of the top of a tower from 2 points. Oh, okay, okay, okay. So what they mean to say is that this is your tower and this is your base, and there are 2 points. One is over here and the other one is over here. Okay,
Okay.
so AB
Yes.
is the tower and C and D are the 2 points on the base. So angles of elevation of the top of this tower from these 2 points C and D at a distance of 4 meter and 9 meter from the base of the tower. So this is 4 meter and from B to D is 9 meter. So can you tell me how much will be CD?
13.
No. B to D is 9 meter. B to C is
Oh,
4
sorry.
meter.
Yes. CD will be 5.
Yes. This will be 90. Okay. This much we know. And okay. They have not given the angles. They are saying the angles of elevation are complementary. Okay, okay, okay. You know what does that mean? That means this, if you take it as theta, can you tell me how much will this be? 90 minus theta. है ना? Complementary na? So if this is theta,
Yes.
this is 90 minus theta. That's what they are saying. Prove that height of the tower is 6 meter. Great, great, great. So we have to find the height of the tower. So let the height of the tower be h na for a moment. Okay, so what we are going to do is we are going to take two right angle triangles because that's what we have. So in triangle ABC, in triangle ABC, uh, tan theta is opposite upon adjacent. Tan theta is opposite upon adjacent. Correct? So
Yes, sir.
tan theta is equal to opposite
AB.
is AB, which is H, and
AB.
adjacent is
BC, that is 4.
4. Correct, correct. Keep this as it is. Keep this as it is because
Okay.
we are going to get surprised now. In triangle, can you tell me which other triangle we will take?
ABD.
Very good. We'll always take right angle triangle. Although there is this triangle ACD over here, because it's not right angle, we can't take it. Okay.
Yes.
Uh, in that also, opposite and adjacent relationship is required as with respect to this angle. Opposite to this angle is H and adjacent to this angle is this BD, 9 meter. Okay.
Yes.
So, tan of 90 minus theta is equal to opposite, which is H,
H.
upon adjacent, which is BD, which is 9.
9.
Now, what is tan 90 minus theta, Upasna?
So,
Tan 90 minus theta is cot theta.
yes.
Complementary relationships. है ना? In trigonometry, chapter 8, we have studied it. Introduction to trigonometry में. Complementary relationships बोलते हैं इसको. Tan 90
Yes.
minus theta is cot theta. Sin 90 minus theta is cos theta. Like that.
Yes, sir.
Okay, so cot theta is h by 9. Now, can you tell me the relationship between cot theta and tan theta? Come on, Upasna.
So,
Cot theta
I,
is 1 upon tan theta. Cot theta is reciprocal of tan theta. Reciprocal
uh,
relations. So there are square relations, reciprocal relation, complementary relation. You need a little, you can say, revision of chapter 8. Watch that video again. Anyways, tan theta is equal to 9 by h. So you see there are two values of tan theta.
yes, sir.
Yeah, just equate them because they both are equal to tan theta. So h by 9 is equal to 9 by h. So h square is equal to, wait. H by 4 is equal to 9 by h. See, I missed h by 4 over here. So 4 nines are 36 and h is equal to root of 36, which is 6. We don't take minus 6 because height cannot be negative. So height of
Yes, sir.
the tower is 6 meter. We have proved it. Right?
Okay, sir. Yes, sir.
All the doubts cleared?
Yes, sir.
I think if you understood these three questions properly, you can solve any question from the exercise now. Any question.
Yes.
Because they are all like complex figures and mostly questions are easier than this.